Okay, today we're going to be solving quadratic trig equations. Have a look at this one. 2 cos squared theta plus cos theta minus 1 equals 0. Now, because of this composition of functions where you have a cosine function wrapped up inside of a quadratic, it can make it look really complicated. So what a lot of students like to do with something like this is use a u substitution here. So we're going to let u equal cos theta. So that turns this into 2u squared plus u minus 1 equals 0. Now, as quadratic equations go, this is one of the easier ones you're ever going to have to solve here. So we'll go ahead and factor this. Has to be a 2u and a u. Constant is 1. It's going to have to be a 1 and a 1. One's positive, one's negative. We're going to need that one to be positive and that one to be negative to give me that positive coefficient of the linear term. And then that makes, using my zero product property, that'll make u equal to 1/2 or u equal to -1. Now, I'm not really interested in u again, so I'm going to substitute my cosine theta back into it. Cosine theta is 1/2, or cosine theta is equal to -1. I know that cosine is positive in the first quadrant and also in the fourth quadrant. So that's a 1 and a 2 and a 2. And I know that that related acute angle, or that reference angle, is going to be pi thirds. And I know this other angle right here is going to be 5 pi thirds. Now, if I want to know cosine theta -1, I will go ahead and just try to visualize the actual graph of cosine theta. And that is -1 when theta is pi. So those are your three solutions to this. Theta is pi thirds, 5 pi thirds, or theta is pi. Now, a lot of students may not want to use a u substitution. A lot of students will go straight from here, this equation right here, to factoring it as is 2 cosine theta minus 1 times cosine theta plus 1 equals 0, and then from there you'll go straight to here. One is not really any better than the other, so that'll be fine. Sir, what does 2 cos squared theta plus cos theta minus 1 look like? I'm very glad you asked that question. This is not like anything we've seen before, actually. Looks like this. And you can see, from looking at this, our solutions to this, in other words, when is it that 2 cos squared theta plus cos theta minus 1 is going to equal 0? Right there at pi thirds, pi, and 5 pi thirds. Exactly like we figured just a second ago. All right, let's try another one. Let's do 3 sine squared theta minus 10 sine theta plus 3. Also on zeros less than theta, less than or equal to 2 pi. Okay, you could do a u substitution on this one, or you could just factor it as is. Equals 0, sorry. Let's see. So that's going to be a 3 sine theta, and that's going to be a sine theta. To get my constant, first of all, I need to have 2 negatives there. And to get a constant of 3, I'm going to need a 1 and a 3. I'll put the 1 there and the 3 there. That means that sine theta must be a third, or sine theta must equal 3. Sir, sine theta can't equal 3. Actually, you're absolutely right, because you know that sine looks like this, and it gets as big as 1 and as small as -1. So sine will never be 3, again, because sine is the ratio of the opposite side to the hypotenuse, and the only way it could be 3 is if the opposite side were bigger than the hypotenuse, which is not possible. And I love seeing something like this because I don't have to do anything. I get no solution on that one. This one, however, I am going to have to solve because sine can be 1/3, so we're going to do theta is sine inverse of 1/3, where I will then go to my calculator And my calculator is going to tell me this is 0.34. Okay, and because I know sine is positive here and here, first and second quadrant, and I just figured out that one is 0.34, that's my related acute angle, then I'll go over here and theta sub 2 has got to be pi minus 0.34, which gives me approximately 2.80. So here I only have two solutions, 0.340 and 2.80. And if you're interested in what 3 sine squared minus 10 sine x plus 3 looks like as a function, it looks like that. And you can see it crosses the x-axis exactly twice, once here, and I guess that is my 0.34, and that looks to be about my 2.0, just a little bit shy of 3.14 there. Okay, so let's try another one. Okay, let's look at sine theta minus sine theta tan theta equals 0. On 0 is less than theta, less than or equal to 2 pi. Now, sometimes even if it's not a quadratic, you still have to factor it. Here's one of those cases. So I pull out my sine theta, factor that out. That leaves me a 1 minus tan theta equals 0, which means that sine theta is 0, or tangent theta is equal to 1. Sine theta, I know from looking at the curve, sine theta is 0 when theta is 0, but 0 is not part of my domain there, or when theta is pi, or when theta is 2 pi. Tangent, I know, is positive if I look at my reference triangles in the first quadrant and in the third quadrant. And in order for tangent, the opposite to the adjacent, to have to be 1, that opposite side and that adjacent side has to be the same. So this is a isosceles right triangle. We get the same thing over on this side. So this angle right here has got to be pi fourths, because it is a 45, 45, 90 triangle. And then that other one right there is going to be 5 pi fourths. So this is going to have 4 solutions to it as well. Again, if you'd like to take a look at the graph, this one, it is going to look really kind of strange. Okay, here you go. This is sine theta minus sine theta tan theta. Not surprised to see a couple asymptotes in it because of the tan theta curve. And you can see it actually is equal to 0 at 0, pi, 2 pi, and then that must be pi fourths and 5 pi fourths. Okay, so that's that. Solving quadratic trig equations. Go do some practice.